Okay, so we want you to compare and contrast, all right? Let's think about, first, ionic and covalent bonds. Second, let's talk about covalent bonds, the two flavors of covalent bonds. Let's talk about polar covalent and non-polar covalent. So go ahead, talk to your partners, and make sure you understand what those mean. And then I will go ahead and elicit answers. Okay, go. If you need a hand, feel free to call a PF up. Okay, great. Okay, so first, let's try to get the definition of ionic versus covalent bonds. Okay, so let's take a look. Nok-che? Nok-che? Yay, okay. Would you like to give us a guess on the definition of ionic versus covalent bonds? Yeah, that's great. So for ionic bonds, one of the atoms takes the electron. Covalent bonds, one of the atoms both share the electrons. Okay, so let's do a quick demonstration. Here's my electron. I am sodium. And what is your name here? Nicholas, would you mind participating in the demonstration? All right, so Nicholas is going to be a chloride ion, okay? Nicholas, the chloride ion, really likes electrons, okay? This is the electron. So he is going to take the electron and hang out with it, and he's not going to give it back to me because he really likes electrons. But now I am a sodium ion, and I really, really am very positive, and I need that electron. So the only way I can get the electron back is to hang out really, really close to Nicholas, okay? I'm just going to stick by him. Great. And so this is why sodium chloride is a very strong bond, right? So outside of water, sodium chloride sticks together and becomes salt. It's a strong ionic bond, okay? All right, so let's talk about covalent bonds, okay? Non-polar covalent bonds. Can I get your name?
Alani.
Alani?
Yeah.
Okay, so Alani is going to be a covalent bond with me, all right? So we are going to share this electron. And so Alani kind of likes the electron. She hangs out with it for a while, but she's a good sharer. She's a good team player. So she occasionally she'll give me back the electron. So I'll have the electron for a while, and then Alani will have the electron for a while, and we both share electron time equally. So there's no net charge for a non-polar covalent bond. Okay, we're sharing the electron. Great, thank you. All right, so let's go on to the next flavor of covalent bonds. Let's talk about polar covalent and non-polar covalent bonds. Okay, so let's see if Kenneth Casper Bauer is around. Kenneth Casper Bauer, go for it. Can you tell us the difference between a polar and non-polar covalent bond? Mm-hmm. Yep. Yeah. Right. So non-polar is what we just demonstrated, right? We both shared the electron. Nobody had a net charge. So what we're going to do is let's try a polar covalent bond, okay? Like water. All right. We're going to pretend to be water. What is your name?
Chris.
Would you like to demonstrate a polar covalent bond? Okay. So Chris is going to be the oxygen. I will be the hydrogen. All right. So Chris, are you going to spend more time with the electron, or am I going to spend more time with the electron? So oxygen tends to be more, it's larger, right? So it'll attract electrons more. So it likes electrons more. So is the electron going to spend more time around you or around these tiny little hydrogen bonds? Or these tiny little hydrogens? Yeah. So the electron is going to spend a lot more time around the oxygen because oxygen likes hydrogen better, or oxygen likes electrons better. Okay. Let me say that again. Oxygen likes electrons better. Okay. Great. So you're going to hang out with the electron for a long time. You want to hold it up? All right. So the electron is hanging out around him, and I kind of like the electron too, so I'm just going to hover around until he decides to be generous and gives me the electron. Okay, so occasionally I will get the electron. Occasionally, okay? But most of the time it spends time around the oxygen ion, okay? So this is why we have a polar covalent bond where part of the molecule tends to be negative and the other part of the molecule tends to be positive, okay? Because the electron is just spending more time around the oxygen. Okay, so this is a very special property of water, and we'll talk about it later. Okay, thank you very much. Okay, yeah, sure.
Just to be clear,
Yeah.
it's not the negative, that they're opposite charges that make that happen. It's the other way around. Like the size of the molecule